guys, welcome back to the King Tira class and welcome to a new series under the King series, Logarithm. For logarithm today, we're looking at two different questions on the logarithm. And the first is this, while the second, is a proof. For the first question, you're looking at the basic, laws on the logarithm. Such as, for number 1i, I have log 27 base 3. Now when you have a question like this, what you're supposed to do here is to see what power will you raise this base to get 27. Alright? What will I raise 3 to the power to get 27? And that's what? That's 3. So I have log 3 power 3 base what? 3. In logarithm also, one of the laws says if I have the power of this logarithm carrying another power, what I have to do is what? Bring this power to the back directly. That's 3 log what? 3 base 3. So this 3 is now this 3. Finally, any log of a number with the same number gives me what? 1. So 3 times 1 gives me what? 3. Finally. So as simple as that, log 27 base 3 is equals to what? Is equals to 3. For number 2, that's 1ii, I have log 27 base what? 3 raised power, base 1 over 3. Alright? Now, which is also the same thing as what? Log what? 3 raised power 3, right? Base 3 raised power what? Minus 1. Now, I change this to 3 raised power minus 1. Why? Because one of our laws of indices, I have a raised power minus 1 to be the same thing as what? 1 over a raised power what? 1. Which is exactly what we have here. This is like me saying 3 raised power minus 1 is what? 1 over 3 raised power what? 1. At this point, for the power's power, it comes back directly by what? Saying 3 log what? 3 base what? 3 raised power minus 1. For the denominators, for the basis power, it now becomes what? It becomes the inverse. So that is, I'm going to have that as what? Instead of multiplying straight up by minus 1, I'll divide by what? Minus 1. So the same thing also, if this was minus 2, I'll divide by what? Minus 2, bring it to the back. So that is minus 1, log what? 3 base what? 3. Again, from here, what do I have? This comes to the back as what? Division. So finally, I have this as what? Minus 3 times 1, which is what? Minus 3. Why? Because log 3 base 3 is 1. This divided by this is what? Minus 3. Multiplied, I get my answer as what? Minus 3. Then for number 3, alright, I have log x raised power 3 base x, which automatically gives me what? 3 log x base x. And finally, I have this as 3 times 1 because log x base x is what? Is 1. Leave my answer to what? 3. Then number 2, what do I have? And to show that all this will give me all this here. So, very simple, by saying what? Expanding, I have what? Log base a of what? Log base a of a squared plus 2ab plus b squared. Then, simplifying further, what do I have? Since I'm working towards this answer, what I can best do here is to say what? Pull out what? A squared. So, if I factorize a squared, what remains? This remains 1 plus 2ab over a squared, then plus what? B squared over what? A squared. Now, leaving my answer to be what? Leaving my answer to be what? Log a squared base a into, this is what? 1 plus 2b over a, right? Why? Because this will cancel one of this out. Then plus what? Plus b squared over what? A squared. Then finally, in logarithm, this a squared is multiplying everything here in the bracket. So I can separate it by using addition. By saying log a squared base a plus what? Log base a of what? 1 plus 2b over a plus what? b squared over what? A squared. Leaving my final answer to be equals to what? 2 plus log base A of what? 1 plus 2b over A plus b squared over A squared, close the bracket. So that is the answer to this particular question. You can see, from our initial question, how that will prove that this gives us what? This. And that's the final answer and the solution to these questions on board. So see you in my next class.